So the title of my presentation is HELIOS version 2, and what this app does is it trains a model in order to predict the probability of a user or a person having a sleeping disorder. So without further ado, I will run the app now. I have already copied the user interface for my terminal. So this is the app HELIOS version 2 sleeping disorder screening. So the first thing that we have is we are going to train the data over here. So this is the data set which we got from Kaggle, This is what we will be using. And I implemented CV folds. And what this is, the value here is 5. What this does is it does the training and validation 5 times just to be able to make sure that it has proper accuracy. And here we have a slider where you can use to select your test size and your training size. I'm going to leave this at 0.2. And then we have our K-grid. So what this system does is it is going to take all these K-grids, it is going to run tests for every single one, and it is going to select the best model. It is going to select the K nearest neighbor with the best model. So without further ado, we are now going to train our KNN classifier model. Right. And when we train this, we can see the result over here. You see an accuracy of 93%. We see the F1 score over here. And if you look at the cross-validation summary over here, you can see all the K nearest neighbors. You can see every single one of them, and you can see their scores. Our system selected 13, and you can see that 13 actually had the highest accuracy over here in terms of F1 score, which is 88.7%. And here we can also see our evaluation in terms of the statistics. So you can see the accuracy here is for the training, we had 87%, 87.9% for our training, achieving 88.3% for our training, and for our testing, we achieved an accuracy of 93%. Now, moving further down into the system, so you can make a single prediction with the system, or you can make a batch description. So for instance, this is a patient here with all this data, so I can make a single prediction and I can just predict the single patient, and based off all of this, it will say, right, this patient, the probability of this patient having a sleeping disorder is 100%, and it is also going to let you know the neighbors that it used to select this data. As of course, we were using our K was 13, so there are 13 values over here that it used to make this prediction. If we toggle with this prediction, these values a little bit, let's say we bring the age down to maybe 20, and we say this person is sleeping for 9.5 hours. The quality of sleep is 8. The stress level is maybe at a 2. If we say their daily steps, let's say they're getting 15,000 steps every single day. If we make another prediction, you can see that no sleep disorder, that the probability of their sleeping disorder has gone down significantly. Again, we are seeing the K nearest neighbors that he's using for that prediction. And here we have, if you want to do a batch prediction for a lot of users, you could do a batch prediction. And so if we're comfortable with this model, we can save this model, and you can see it is going to save the model so we can load it and use it later on. That is my submission. Thank you very much.